Good morning, all. Good morning, all.
Good morning, sir.
Good morning. It's my pleasure to have today's speaker, Dr. Yash K. Chavan, sir, from KJ Somaya Institute of Engineering and Technology. In a brief introduction, I can say that sir is having more than 25 years of experience in the area of teaching various subjects, including graphics, animations, and so many other subjects in the area of computer engineering. Sir is currently working as a professor in KJ Somaya College of Engineering and Technology. We have worked together for on so many different topics, etc. So welcome you, sir, and thanks for accepting our invitation for the Expect Talk.
Thank you, Professor.
Yeah.
So let me share my screen and then I can start. Is it visible? Hello?
Yeah, it's visible, sir.
Yeah, fine. And I'm audible as well, no?
Yeah. Sound required to be increased.
Okay, fine. Is it fine, sir?
Uh,
Still not?
some louder required.
Just 1 minute. I'll make it maximum. Fine? Hello?
Yeah, it's
Now is
okay.
it fine?
Yeah.
Yes, sir, it is
Yeah,
fine.
it's fine.
Yeah, okay. So, good morning, students. As our topic is techniques for realistic animation, I think we need to start the basic things where I would like to understand from you one thing, which is computer graphics. So, if my simple question is whether the computer graphics is in the computer graphics, two words are there or three words are there, then what is the probable answer? In computer graphics, is it there are two words or three words? How you will describe computer graphics or what exactly computer graphics means? So I hope in computer graphics this animation or the topic which you would like to understand today might be the last topic of your interest. So what I have done is I have considered only two key points, excluding mathematics, because I think in online session it will be difficult to justify the mathematics and its involvement in computer graphics. But I hope for rest of topics, including your DDA, Bresson algorithm, circle drawing, or whatever, the core part is always a mathematics. Obviously, in animation, also it can't be without mathematics. But what I done is I have kept all things simple. What I mean to say is I have included only theoretical concepts which will be easy for me to describe and for you to understand. And considering I hope you have completed the C++, I have considered very simplistic animation for Starfield. I think hardly it is a 10-15 line program which I'll try to elaborate at the end of this session. So to begin with, for today's agenda, it is introduction to animation, then traditional animation techniques. Why I've considered traditional? Because where it has begun and where it has been reached, we want to understand the difference between these two. So a bit, I think 3 to 4 slides I have dedicated to the traditional animation technique. Then we will talk about the principles of animation, and obviously the last section will be the character facial animation, deformation. Don't take the actual word of deformation. And at the last, we'll talk about the motion capture, which is the integral part of your animation. So I hope you might have gone through your textbooks, and the picture which I have represented here is one of the picture which is given in your hand, and Baker, which is your. I hope it is a textbook for you. Okay. So, even though I have defined what is animation, which is given life to something and making it alive and all that, but let me tell you about the animation. And as I said before, animation, it is related to the computer graphics. So, as I said, whether it computer graphics, how you elaborate it. Obviously, we all know computer, but the moment you think about graphics, it will be graph plus the pics or pictures. I think the short form of picture which you most of the time used to use is pics. So graph plus pics result into graphics. So I hope in that way, if you think, and the moment you think about graph plus pics and the way by which you would like to represent, then we need to consider a simplest example to understand what is the need of graphics, why we need to understand computer graphics, what is the requirement of it. So if we consider simplest case, for example, the case of suppose kids garment, or consider you as a CEO or proprietor of a kids manufacturing or kids garment manufacturing company. The moment you think about, you would like to represent or you would like to keep this statistics related to the sale of your company for last 5 years. The very first thing which comes in your mind, it might be the large amount of data. The reason for large amount of data is it is a kids garment manufacturing company. You might have n number of outlets, n number of categories of products, and daily sale, hourly sale, monthly sale, weekly sale, yearly sale, and like this you would like to represent for last 5 years. So if I start describing what is hourly, monthly, daily, whatever sale is, it will be too cumbersome to represent and to understand. But the moment you will draw a graph for the same, it becomes an easy for us to understand. Because I hope the graphics and the way by which we are representing this will be easy to get, easy to elaborate, easy to understand. And I think that is the main reason behind the computer graphics and to study all this. So the graphics tools which are used for representation, for example, the charts, graphs, that can be represented in pictorial form. And as we all know, a picture can understand easily in just a single look because it gives representation instead of textual information. And I hope when you think about this interactive computer graphics, then we must think about the animation as well. And so, in the very first line itself, how we have defined animation is nothing but to give life to. So, when you think about animation, how we can describe it, or how animation can be generated, or what are the key principles for animation, that is the thing which I would like to elaborate to. So the first thing, how it is possible for us to watch movie or cartoons or any serial or the different OTT platforms and all that. The reason is on TV, especially the sequence of images have been presented, and minimum if you present 30 images or 30 images per second, we feel that things are moving. So I think Saturday Morning Cartoons, that series have been started long back in 80s, 90s, 2000. And this is the basic which is used for generating, I think, animation. So if you think about 6 different images per second, then for each image you have 5 different variations in it, then it will represent or it will satisfy the requirement of animation. Uh, One more simplest example to understand what exactly animation is nothing but I think when you haven't started the fan, then we can see or observe or three blades of fan. But the moment if you increase or if you start the fan, then it will start rotating, and then you can't separate the three blades from each other because you feel it is rotating, because the moment the speed of fan goes beyond 30 images in a second, you feel it is a circular fashion. The same thing can be achieved in animation as well. As I just said, if minimum 30 images or 30 frames are moved in a second, you feel the moving impact of it, and that is what animation is all about. So, what are the different applications of animation? Obviously, the animations are used in entertainment, the one which we have just talked about, in advertisement. I think this is the best industry where the animation is used most of the time. The simplest example which you can see is if the Apple phone, or if you would like to simulate something, uh, for advertisement, for teaching, for training. The moment you think about for training or teaching, I think this is the reason why computer graphics is today. So, as we all know, I think most of the innovations are part of the events defense. And I think the internet, which we are using for delivering this session or to understanding the animation component of computer graphics, that DARPA or Defense Academy, they have invented the network or computer network or internet, what we can say. The same, I think, the defense of US, they have invented computer graphics as well, as per I think the literature which I have gone through. But what is the need of computer graphics? Why they invented computer graphics? The reason is, if you are considering the defense of US, they would like to train the pilots. And as we know, I think when you think about the training of four wheeler, I think the person who is sitting aside to you used to control, and you feel you are only controlling. But the same thing may not be true for training of pilot. The reason is, if there is something uneven happening, then it may cause to the life of pilots. And that's why I think for training of pilots, airplane simulator has been used and developed, and that is the need at that time. And I think you might have gone through, this is the basic requirement, or this is the need for simulation or animation, wherein you are creating the environment as that of the plane. You are trying to create almost all situations where you need to take control, and you have to either land safely or take off safely. So the moment you think about training or teaching learning process, I think animation is most useful. Now coming back to the heritage or the traditional way of animation is, the animation can be represented in the form of art. And I think long back there is a great history for animation. Since 1920 it is there. And I think gradually we have reached wherein we are combining the animation, only not only the sequence of movements of frame, but at the same time we are trying to combine or integrate the sound and the effects of it to get the realistic impact of that. So I think these are the few historical pages which I got on internet, wherein how they started. Now if you look at this, what they did, they have described every frame, every single image, for the particular action, what need to be done, and how a particular scene has to be created. So all this description, and accordingly they are drawing the different pictures or sequence of pictures with a minimum change, because that is the base for I think animation. So how animation can be generated? The simplest way is, you can either change the size. what I meant to say is the moment if you think about uh, a particular thing, for example, this wheel, and if it is moving, then I can change the size from smaller to bigger to make the impact how it is growing or shrinking, or we can change the color of it. But initially, I think at the older days, it was only black and white, and then gradually it has been changed to the gray color. And nowadays, I think we can observe the color impact. So, change in size, change in color. The last part of obviously this session will be change in structure itself. So, can I give the morphing effect of a particular image by which I will try to create the different image from the image which is with me? And here comes, I think, the difference between image processing and computer graphics. So, can anyone tell me, if at all you are listening, what is the basic difference between image processing and computer graphics? Students? Is my slides are visible and moving?
Yeah, yeah.
Yes,
It's
sir.
up.
Okay.
Yeah.
So if you think about this,
Yours be interactive.
at least one student, can you tell me what is the basic difference between the computer graphics and image processing? How you understood, how you will differentiate between these two?
So computer graphics is a process in which generating, manipulating, all the things takes place.
Very
But
good.
whereas in image processing, only the processing part of the image takes place.
Fine, fine. Very good. Anyone else?
Mox.
Okay, so as per my knowledge, I think the main or basic difference between the image processing and the computer graphics is when you think about image processing, the image is already available, and then you will try to manipulate it. For example, if you have taken the image from camera, and if you would like to modify it, I think we all know the filters which we are using in social media. So you have already image with you and you are trying to modify that, or you are trying to manipulate that. So that is what manipulation of digital images, which is a part of image processing. But the moment you think about computer graphics, it is a creation of images. For example, this image can be created by using computer graphics, and that's why I said it is computer graph plus pics. And the moment you think about the different pictures which has been created by using computer graphics, the base is a pixel, and this pixel which talks about the resolution of your system as well. So if you have high resolution image, the images which you are creating by using computer graphics will be more realistic, more appealing. Are you with me? So there are, I think, here it is of animation, and I think this Avatar is the movie. I think you all might be knowing about it. And since then, I think computer graphics and animation have been used hugely in industry. And if you think about this, I think the heritage of animation, Tom and Jerry, and all these things, we are interested, and we keep watching for us together all this because it is more appealing. It becomes nowadays more and more realistic. But if at all you think you want to be a graphics creator or animator as such, then what are the different companies which are available in India? Obviously, the one which we have listed here may or may not be available when you will pass out. The reason might be the huge competitions. Why I'm saying huge competition? Because the two companies which I have listed here related to the animation. The first one is Maya Entertainment Limited, which is located in Mumbai. Especially the headquarter is there in Mumbai, established in the year 1996. And even though I say these companies are available in India, might be started by, I think, foreigners itself. You can check the revenue for these two companies, Maya Entertainment Limited and Any Brand. I think the one which is located in Pune. Four out of three out of four directors are not Indian, especially for any brand. And the statistic says it is approximately 100 crore company. But I'm not going in detail of this because I think these statistics talks about the any brain and which talks about how much competition is there and how they are surviving. But the moment you think about the innovations, because nowadays it will be very difficult to have um, the what I guess brand ambassador and his cost. Instead, you can innovate a particular thing which will be more appealing by use of animation, and it will give greater impact than brand ambassador for the advertisement for creation of impact on customers. Because the ultimate aim for animation or the computer graphics is need or use as per requirement, and that's why I think it has a great future in the future as well. Fine. So to move further, the first takeaway which I would like to discuss with you is the computer animation basics. And I think as per the your standard textbook, these are the four animation basics which you need to understand whenever you are generating the animation. The very first is storyboard layout. What exactly storyboard layout means? Obviously, the storyboard layout gives you the outline of the action. What I mean to say is, the moment I say it is an outline of action, it talks about what exactly that scene consists of and how you can make a sequence of actions in that particular scene, and that sequence of actions can be outlined ahead of time in order to generate the impact. What I mean to say is, to define the motion sequence for this a particular action as a set of basic events. The moment I'll say a basic event, for example, if you would like to give the morphing effect for the human face, then simplest way to represent the human face might be a circle, and that within circle the different events can be generated to give the impact. So for example, the human face might be blinking his eyes. That effect can be generated by the sequence of events which takes place to represent that animation. So this storyboard layout actually represents a clear cut outline of an action. And obviously, to represent this clear cut outline for the set of actions, you need to create. Obviously, in the older days, as we have seen, historical perspective is there for computer animation. They used to generate a sequence for different actions, and that every sequence have been described, and for that they used to sketch and they used to generate these sketches. So set of rough sketches which could represent the basic idea for the motion is nothing but storyboard layout. I hope you are with me and you are understanding what exactly storyboard layout means all about. The second thing which I would like to talk about is the object definition. The moment you think about object definition after storyboard, which talks about the outline of an action, it gives me or the object definition talks about each participation in the action which you are sketching in the storyboard layout. So these objects can be defined in terms of, I think, basic primitives of computer graphics. And the moment you think about, instead of saying basic primitives, the primitives itself, and which might be the different shapes. For example, circle, triangle, it might be a polygon, it might be a spilines and something like that. So all these primitives have it can be associated for the movement and for each object that have been specified along with these shapes which you are using the computer graphics primitives to generate the impact or the moving action as such. Then comes after, I think, storyboard layout and object definition, wherein you are talking about the set of rough sketches, the sequence of actions, then what each object uh, does, or what is the task of each object which play a role in the particular action, which is outlined in the story layout. Then we need to think about the keyframe specifications. What exactly keyframe specifications means? See, the I think good example for keyframe specification might be Bumrah. Then there are two things which involve in the representing or animating or displaying actual what exactly Bumrah, how he releases the ball. So when Bumrah release the ball, then what is the past action? Past action means not related to the batsman, but most of the time, I think, instead of saying most of the times, few times you might have observed after releasing the ball, Bumrah could not control himself and he may fall down because of that speed, because of that action, because of other things. So if that impact you would like to simulate, then we need to identify what is the start, what is the end, and what is the impact. And for that, you need to identify the keyframes, and that can be done by doing detailed drawing of the scene. Now, the moment you think about Tom and Jerry, and if Tom hits Jerry or Jerry hits Tom, then after hitting, what is the response? How you will represent that? That can be represented with these keyframes. So, drawing detailed scene for a certain time, and that can make an animation sequence, and that can be represented with the help of these keyframes. So these keyframes should be positioned accurately. That means if you would like to represent an animation sequence, and as we have already stated, minimum 30 frames per second are required, then all these 30 frames can't be your keyframes. I hope you are getting me what I'm trying to pinpoint. So between two keyframes, there might be some frames which actually represent the sequence of actions. So if you have all keyframes, then I hope you may not be in a position to generate the impact which actually you are creating with the help of these keyframes, which is in between the sequence. That means where exactly it need to start and where exactly it need to finish, and how you will generate the impact. And that's why after keyframe, the last part of animation basic is generation of in between frames. So the moment you think about it, in between frames, these are the intermediate frames. And I think yesterday only I have seen the advertisement of Google phone. I think it is Pixel 8. And when I was reading the features of this, I think Pixel 8, the smartphone launched by Google, I understood if you are taking a snap by using this Pixel 8, what the Pixel 8 does is it will take a snap, not a single snap, within the time frame when you are clicking the button, and it will generate, I think, 5, 6, 7, or more than that frames. It will try to integrate good features from all frames, and it will give you very good snap of the thing which you are taking up. So these the frames which are generated in between are of use to generate the sequence of motions as well in animation. So a particular film which requires 24 frames per second, especially in computer graphics for I think terminals. When you have studied the basics or hardware for computer graphics, you might have come across the term which is called raster graphics. And all these raster graphics, which are the computer terminals, which are refreshed at the rate of 30 to 60 frames per second, and that's why we can see it is moving. or the letters or the characters have been displayed. And the moment you think about these characters, if it is not inkjet printer or ink printer, then or if it is a dot matrix printer, then every character I think you might have understood in computer graphics itself, which is made up of the smallest picture element, which is called as pixels. And these all pixels must be refreshed with the rate of minimum 30 to 60 frames per second. Then only you can see that character continuously on the screen, otherwise you can't. And that is the illusion which has been created. Actually, your character is not displayed continuously. I hope that basics you know. But what I'm trying to pinpoint is, if you are considering all these things, that means 24 frames per second or 30 frames per second, and if you would like to generate a video or animation video of 1 minute, then it might possible you require 100 instead of 100. I say thousands of frames. And out of these 1,000 frames, how many exactly I could understand, or I got approximately 1,500 frames. Please go through the exact number. It might be 1440 or 1450 frames, number of frames which is required to generate a sequence of effect, sequence of motion, or instead of sequence of motion, a video. So all these 1400 or 1500 frames which you will be using to generate the animation can't be a keyframe, and so you require in between keyframes. In between frames. So if you have suppose 5 to 6 keyframes, then in between 2 to 3 in between frames can be used to generate the impact. I hope you can make the difference between the keyframes and in between frames. I hope when we will talk about the other parts, I hope I can make out what is the difference between the keyframe and in between frames. Okay. So in the traditional animation technique, I think we talked about animation rapidly displaying the sequence of motions to create the illusion of movement and all these basics. So I think if you have different photographs and if you would like to create the impact, then what is the first thing which is required in this case is the time. How timely you are generating. And I think when think about these parameters, I hope what we require and what we need to follow is the fundamental principles of these computer graphics. So I think your book talks about 2D animation, 3D animation. The moment 2D animation, we are talking about only the planes or surfaces, but the moment you think about the 3D animation, you are generating third angle. Third angle means X, Y, and Z, and I think box is the simplest. And if you think about the 3D animation with which you can start is the try to draw a cube and rotate it about the apex. I think you will get very good 3D animation by which you can generate the 3D impact. Okay, coming back to the animation techniques and the fundamental principles about it, we can think about the different principles for producing good computer animation as such. So in which the very first thing is squash and stretch. I think we can understand don't take exact meaning, because squash and stress means when you think about generating I hope suppose a particular computer primitive has been given. For example, if it is a rectangle, instead of rectangle take square or rectangle, fine, because it gives you the different impact. If I consider square, then I can transform this square by shear operation. Again, it is the 2D transformation you might have studied, by which you can change the shape of the 2D object. And if you stretch a bit, you can change this rectangular square into an arrow, which might be my second slide. Second one is the timing. The moment you think about timing, I think it is the great thing which we need to talk about. So if it is a great timing as such, because time gives you the things which are required in the animation. So the moment you think about what exactly time related to the motion and how it plays a key role, you can think about the impact which is generated by this timing. Now if you see the squash and stretch in the bouncing balls, if I change the speed, then below the number of frames which is generated by within a fraction of second, or within a second, as we talked about minimum 24 frames or minimum 30 frames, then it won't give me the moving impact of it. So when and how you will be using the time frame for motion sequence, because I think one of the example here, if you can see, what do you anticipate, which is one of the principle for generating animation. So the moment you combine these two things, the two things means first is the what I can say time, and second one is the anticipation. In this particular thing, you are thinking about how Goopy he is preparing himself to hit the baseball. Okay, so in the same way, if I think when you think about this anticipation, I think nowadays the ICC Cricket World Cup is going on, so you can make immediate comparison of this hitting a baseball. What is your anticipation, whether Virat Kohli will hit a six or whether Rohit Sharma will hit a six, and who will make it easy to hit the six? What is your anticipation? And the moment you think about this anticipation, very first things which comes in your mind and which the I think commentator talks about is the timing of Virat Kohli and timing of I think Rohit Sharma. So the anticipation and timing, when you will combine together or integrate together, it will give you great impact or result of that animation. The second thing which I've just described before 5 minutes, what is the staging, what is the follow through, and what is the overlapping action. I think if you think about this follow through and overlapping action, I think you can make out immediately after pitching the ball, after releasing the ball, what is the action and what is the follow through of bowler. Because most of the time it will be very difficult for the fast bowler to get the catch back, and that's why I think in case of spin bowler we most of the time see catch and bowl, or bowl and catch immediately by these. So now I think considering that example, and considering that means example of crickets, as you might be interested in this, that's why I'm giving this example. So what is a follow through, what is the overlapping action, and what is the termination part of it? All this makes a great impact on the animation. So you, whenever you are thinking about the uh, principles, you need to consider all these cases wherein you have to think about the principles which you need to follow. So I hope this is the third principle, anticipation. Staging is fourth one, follow through and overlapping action. Now I've just covered, I think, first five principles. Can anyone tell me what was the first principle which we talked about? Anyone? Because this indicates whether you are listening or not. So I think first two principles which we talked about. Was the what are these first two principles which we talked about? Because my I think my current slide talks about the timing, anticipation, staging, and follow through. What was the previous two? Obviously, first one was the squash and stretch, and second one was timing and motion. So I hope you understood what exactly I'm trying to pinpoint, because these are the two takeaways which you will be taking for animation. What are the takeaways? What you will be taking? What you will be considering? Obviously, the first thing which we have covered is related to the basics of computer, wherein we talked about four things. One is storyboard layout, second one is object definition, third one is keyframe, and fourth one is generation of in between frames. Now, the moment you think about the last two, which is keyframe generation and generation of in between frames, you can think about this staging and follow through and overlapping action or anticipation. So, all this, I think, here for every step, every principle of animation, you require a keyframe and in between action. For example, after follow through, what is the overlapping action which you are trying to represent, that might be represented with the help of the generation of in frame in between frames as such. Okay, so last one is overlapping action. I think I have made it separately to make it clear what exactly overlapping action is, and I think this simulation or this animation immediately make out what exactly the overlapping action means. Okay, so coming back to the principles of animation, the next principle is the straight ahead action and pose to pose action. So, what is the straight ahead action and pose to pose action? And what is the next in it? The next one is slow in and slow out, I hope. So, now consider this straight ahead action and pose to pose action, and next one is slow in and slow out. When you think about these two principles, I think immediately you may make out, if at all you are thinking about the animation or the character which you would like to animate, for example, the robot. If your robo will move like a robo, it will not give you a feeling. But the moment you want to make the realistic movement of robot, then you have to think about, instead of straight line, a curved, a bit curved line. Okay, or a pose to pose movement of sequence. So what and how a normal human being moves, in the same way you would like to simulate the movement of the robo, then instead of these straight line actions, you would like to represent the pose to pose movement, and that can be simulated. The next is nothing but slow in and slow out. I think immediately you can make out from this, I think, animation, the sequence wherein I think lift have been simulated. So when you would like to demonstrate the working of the elevator or lift, what you are doing, when it will reach to the destination, it will make the keyframes sequentially try to achieve. In last few seconds, it will be a bit slower as compared to the actual motion, and that is what the sequence for slow in and slow out. I hope when you think about any realistic example as such, where exactly you would like to, you need to slow the sequence of frames to give the impact, that need to be considered as one of the principle for animation. Next is arcs. I think already I talked about the straight line and arcs to give the natural movement. You need to use arcs, obviously. The next one is exaggeration. So instead of doing something, you emphasize the essence of an idea for design actions, and it need to be designed carefully. Then I think it comes secondary action, and last, obviously, the 11th might be principle of animation, which is appeal, and which refers to the audience or obviously end users. whether they like it or not. Because a particular character, a sequence, the one which you would like to represent, but it's too simple, it should not be boring, or if it is too complex, then it might be very difficult to understand what exactly happening in the animation. So keep it simple, easy to understand by doing frame by frame action. And I think all these steps, especially the bouncing ball, I have taken from Wikipedia. Obviously, we need to understand the number of frames per second, and already we talked about when we will get the moving impact, if only if you have more than 30 frames per second. So if you want to understand this frame by frame animation, I think this is the good example which I could found on internet, where immediately I think you will understand how you are representing, or you are simulating the impact of it. So this is called animation or simulation, where you are achieving the impact or result, uh, where you are giving the different frames. And if you make it bit faster, I think you will get it is really moving, or it is really doing that impact. Here I have kept that sequence for I think 1 frame per second, and that's why you can make out the difference, what was the previous and what was the new impact of it. Now, I think you might have observed, and the one which I've talked out in between is related to morphing effect. So, when you have a particular primitive of the graphics, for example, if the beginning shape is something like this, which is a rectangle, instead I'll say a square, and if the end shape which you expect is related something like this, which is shown here as an arrow, then how you can make with this beginning image to the end image, how you will change it for a period of time in the sequence of images which you would like to convert. And that impact can be given with the help of morphing. And I think this example gives you the realistic effect, how you are changing the frames per second to make it an arrow from the given basic shape. Okay, fine. So this is what is the related to the sequence, or what I can say, the animation principles and animation basics. So related to animation basics, I think we talked about the 4 things. Can anyone list the 4 things which we talked about the animation basics? Anyone? So I'll come to know ki you are really there. Fine.
Student, reply to the questions. Session should be interactive, right?
So, storyboard layout, object definition, keyframe specification, generation of in-between frames.
Very good. Thank you. Okay. Coming back to the last section where I would like to simulate, I hope you might have done this, but still, what I'm trying to represent is the simplest way by which we can understand the simulation or animation in C. Actually, I wanted to demonstrate how you can generate the moving object in Python, but then I've decided you might have done the practicals in C, C++. So I came back to the C and wrote a simplest program. So what this program talks about, actually, if you if you take a moment and check this program, I think this is the simplest way to understand it. First, what I have done is, for I think embedded graphics, detect GD and GM2 variable for graphics we require for what the purpose is to initialize the graphics adapter. And the second one, third parameter instead of paragraph, third parameter for this init graph is the library, which actually talks about the interfaces as such, and that interface is related to the Borland graphics interface. Now, the moment you think about interface, the very first things make comes in your mind is GUI, graphical user interface. The second is, instead of UI, nowadays you might be thinking about UX, because which gives you a better use and feel than UI. But still, okay. When you think about the simplest program to simulate something by using C language, what we can consider is these three parameters by which we can initialize the graphics card of your system, and then we'll start interacting with it. So what I did is, even though I have taken the outer loop, which is while loop, with no keyboard hit, this does mean the moment it is a keyboard hit, it must exit from the program. But the problem is, if you check the inside loop which I have taken, it is for loop with I equals to 0, I is less than 200. And within this loop, I have given a delay of 100. So 200 multiplied by 100, it comes 20,000. And 20,000 millisecond means 20-second delay, approximately. Are you with me, students? And then the outer delay is of 1500 milliseconds. So I think 1000 millisecond means 1 second if you are considering. Then this is the delay of 1.5 second to refresh the screen or to clear the device and to regenerate it. What is my simple way of displaying it? I am generating the X and Y coordinate to display a particular pixel by using the rand function, which gives me a random variable instead of random variable, random number, to which I'm dividing. Instead, I'm taking a mod of it by get maxes. So based on your resolution, you will get maximum X value, maximum Y value, and you are taking remainder of it, by which you will get distributed coordinates of your screen. And then I'm taking the pixel value as well, pixel third value, which is related to the color. So if I'll get X coordinate, Y coordinate, and the color of pixel, I can use the put pixel, I think, function to display it. And if this happens continuously, it gives me a simulation effect. So I hope this is visible, or the different pixels are visible on your screen. For example, if I start execution this, so I have recorded a video for you. I hope you can generate this, you can see the impact of it. And I think in older days, the Microsoft Windows used to give the animation or screensaver, which is a Starfield simulator. Even though I have given the name as a Starfield simulation, it is not actually Starfield simulation, because these pixels are not that clearly visible. So instead of this pixel, if you use, I think, any graphics primitive, for example, a circle, which you are changing with time, then you will get truly a Starfield simulation impact in C. Okay, so this will go on till I'll hit any key from keyboard. I hope you are making or you are observing. It will refresh my screen after every 1.5 seconds, but before that, it is taking approximately 20 seconds to display the pixels on screen, because the inner loop is for 200 pixels and 100 I think milliseconds delay. So here it is trying to display the pixels on screen, and then it will continue. Okay, so this is all about for today's animation. And I think to summarize the things which we have covered, obviously we talked about, and as I said, there are two key takeaways for you. The first one is the basics of computer animation, and second one is principles of animation. If you follow all these rules and regulations, instead of rules and regulations, I'll say principles of animation, you will get true or realistic animation. So the four basics: storyboard layout, object definition, keyframe specification, and I think you can make out difference between keyframe specifications and in between frames. Similarly, you can make out difference between the different principles and their need. So obviously, whenever you would like to list the principles of animation, you please start with time, which plays a key role in your animation. So students, that's it from my side. If you have any questions, you can. Okay, Professor, I think no questions.
Okay, student, if you're not having any question, then we can stop out here. I thanks Dr. H.K. Chavan sir for sharing his valuable knowledge with you all. I appreciate him for sharing his knowledge in the area of animation. He had covered certain types, certain part like animation slides. He had included in the presentation itself for making it more interesting for you guys and to learn how to do the animation. He explained about the heritage of animation, animation industry, the traditional animation techniques, morphing animation, principles of animation. Apart from that, he had given demo of the Starfield, so you can get some idea that how some animation kind of programs you can do in C language itself. So what is part of your submissions also, right? So I thank Dr. H.K. Sawan sir for his valuable time. Thank you very much, sir.
Thank you, Professor.
Yeah.
Thank you, students.
Yeah. So, sir, can we close this meeting?
Yeah, please, sir. Yeah,
Yeah.
thank you.
Thank you, sir.
Yeah.
Thank you all. Bye bye.
Yeah. Thank you.